All right, in this video, we're going to talk about rational functions. Rational functions are functions of the form where you basically have a ratio, right? Rational ratio, that's what that means. So I'll just say, well, actually, no, we'll say it's okay. Where y or f of x is equal to p of x over q of x, where p of x and q of x are both polynomials. Yes? Say it again. Oh, great. Love that. So, one moment, please. We're having a technical difficulty once again. Okay, sorry. So, the document camera had frozen. So, P and Q are polynomials. And Q of X cannot equal 0. In other words, the denominator cannot equal 0. One of the simplest is the reciprocal function. You can kind of see a reciprocal function here on the left side. This is your parent function. This is just the graph of y equals 1 over x. That's all it is. Okay? So again, this is f of x equals 1 over x. That's the parent function. Okay? An asymptote, in case you didn't already know, is a line that the graph approaches. A line or a line which the graph approaches. Some of you have these notes, so my apologies. We're just going to get the vocab, and then we're going to kind of go from there. In the graph to the right, there's a vertical asymptote, and there's a horizontal asymptote. The vertical asymptote is right here. I'm drawing that in red. So it's x equals -3. Okay, and the horizontal asymptote, I'll draw that in orange. That's right here. And that's y equals 1. Okay. So I'm just going to do a quick overview, and then we'll kind of go through a couple of these step by step. It's getting you all the information in the beginning. So that's what a vertical asymptote and a horizontal asymptote at least look like. And a hole is actually when you have a 0 on the top and the bottom. So if you notice here, you'll see that there's a common factor. And this common factor means what number gives you 0 over 0? What number gives you 0 over 0? X equals, you can say it, 2? Yeah. So there's a hole when x is equal to 2. Now what you'd actually do is you'd take that number 2 and you'd plug it in to the simplified version of this, and you'd get 1 over 2 minus 1, 1 over 1. So it's at x equals 2, and it actually is at y equals 1. So that's the hole right there. Okay. Okay, so if we look at some examples, so what I'm going to try to do is like a little side-by-side view here. I'm going to try to jump into an example that has, you know, kind of a lot of stuff going on with it. And at the same time, I'll pull up this paper that hopefully you have. So we're going to kind of try to follow these rules. Okay? And then just give me 1 second to kind of pull an example and follow these rules with it. Okay? So these are your step-by-steps. All right, so we're going to go through the first example, number 1 here, and just kind of take it step by step. We'll do some color coding to do a better job. The first couple things is that you want to factor it if possible. There's really no factoring to do here. It's already factored, right? So I'm just going to go ahead and kind of show that there's nothing to factor, so I'm just going to kind of check that off. The next thing that we want to find is the y-intercept. So sometimes you want to do this with the domain and range last, because once you have it graphed, the domain and range are really easy to find. That's just my personal opinion. You can get the domain and range first if you want. Let's look at this. The y-intercept occurs when the x values are 0. So what we need to do is, for this one, which is our first step, we're just going to plug in x equal to 0. So we'll do some nice color coding here. We'll plug in x equal to 0. So when we're finding the y-intercept, that's going to be 1 over -5. Right, if we put 0 here and here. So we'll just go over here, and when x is 0, y is negative 1 over 5, or 1 over negative 5. That's it. That's the y-intercept. Plug in 0 for x, get the y-intercept. Okay, how do we find the x-intercept? That occurs when only the top of the function is 0. So we want just the top to be 0. So here we are, we're going to go blue, I guess. We want just the top to equal 0. So when the top is equal to 0, that's the x-intercept, because when the top is equal to 0, the whole thing's equal to 0, correct? 0 divided by any number is 0, right? So if the top of a fraction's 0, the whole fraction's 0. So we set the top to 0, x plus 1 equals 0, so x must equal negative 1. That's the x-intercept. It's when only the top equals 0, not the bottom. I'll talk about that in a little bit. So that means we're at negative 1 comma 0. That's the x-intercept. Why don't we plot it? We'll plot this one, right? Why don't we plot this one? It's hardly down at all, but it's like right there, I guess. Okay. Now let's go to the vertical asymptote. Now this is where it gets a little tricky. It's when just the bottom equals 0, nothing else. Just the bottom, not the top. Sometimes the bottom and the top equals 0, and that's a different situation. So vertical asymptote is when just the bottom equals 0. So I'm going to put VA for vertical asymptote, and I'm going to set the bottom equal to 0, and that's going to give me x equals 5. So I have a vertical asymptote when x is equal to 5, because I can't divide by 0. So there's something awkward going on there. We're going to go to 5, and we're going to draw in our vertical asymptote. Okay. Then we can talk about horizontal asymptote. Now, horizontal asymptote has a few different rules. Let's see if we go to that next or something later. Okay, holes. Holes are first. That happens when the top and the bottom are equal to 0. For right now, with this example, you don't have a hole, because there's no place where the top and the bottom are the same factor, and they'll both equal 0. Does that make sense? If this was x plus 1 over x plus 1, we could have a hole. Okay, so none, no hole. Let's just put none, I guess. What have we not used? I don't know. We'll go to purple, I guess. So none. So that's this guy. Okay, we'll deal with one that has a hole later, but it's not bad to start with one that's a little tricky, less tricky. Okay, horizontal asymptote has 3 different situations. Okay, imagine this. Okay, horizontal asymptote has 3 different situations. When x gets big, that's going to give you your horizontal asymptote, right? Like it's going to get really big, right? And it's going to eventually get so big, and then it's going to hug a line, right? So if x is going like this and it gets really big and it hugs 0, that's a horizontal asymptote. So let's imagine something where the top, let's say the top is heavier, so we have a higher power here. We have like an x to the third plus 2x minus 1, and here we have x squared plus 5, okay? Well, if it's top heavy, the top is a higher power, there's going to be none, because it's going to go to infinity or some giant number. It's not going to go to 0, because the top is bigger than the bottom. And so, in a way, the third power will kind of pull this away from. It's not going to settle. It's not going to like be like a bouncing ball that eventually sits on the ground. You know what I mean? It's going to diverge, basically. Okay, let's talk about bottom heavy, though. When it's bottom heavy and you put a giant number in, let's just go over here, and we had like x squared, or let's say 2x squared minus 5x over like 4x to the 4th plus 3x squared. Where's the higher power? Where's the highest power? In the bottom. If the bottom has a high power, it's kind of like what's going to happen is you're going to have like some number, let's say 1,000, over a bajillion, right? What will eventually happen here if this has so many zeros? If this has so many zeros, what will eventually happen? Eventually, you'll get a horizontal asymptote at y equals 0. And if they're equally heavy, you actually just take the ratio of the two coefficients. When they're equally heavy, you take the ratio of the two coefficients. So let me show you one more. Let's try y equals 2x to the third minus 4x squared over negative 3x to the third minus 2x. Do you see how they're both third power? That's the highest power. Well, since they're equally heavy, you actually just take the two coefficients and divide them. So the horizontal asymptote for this one is y equals negative 2/3. Okay, let me ask you this. Is this top heavy, bottom heavy, or equally heavy? This one right here that we're doing. Equally heavy. So all we're going to do is we're going to look at the ratio of the coefficients. Because this is a 1 and this is a 1x, they're both to the same power. Our horizontal asymptote is going to be y equals 1. And we'll have something right here. Okay? Sure. So our horizontal asymptote is y equals 1. So now we have a lot of information. We can kind of graph this thing. It's not great, but what we're going to understand is that we have a dot here, so we're going to hug this line and then go down forever. And then most likely we'll be here. If we want, we can plug in 1, 2, 3, 4, 5, 6, maybe 7. If we plug in 7, right, for x, we have 8 over 2, which is 4. So 7, 1, 2, 3, 4, 5, 6, 7 goes to 1, 2, 3, 4, like around here. Doesn't really matter. We just need to make sure we have this kind of shape here. Okay. Finally, we can do the domain and range. Can you see those? Okay. All right, cool. The graph. So finally, we have the domain and range. I just want to look at what x values and what y values did not get graphed. So negative infinity until 5. Whoops. And then 5 until infinity. Those all got graphed. That's a positive, sorry. The range, negative infinity until what value did not get graphed? 1. And then 1 to infinity. And that is an example of a rational function. So that's an example of a rational function which didn't have a hole. That's the only thing it didn't have. Other than that, it had most everything. It's a pretty good example. The video is already long enough, so I'm going to stop here. But I would have you, if you're looking at this sheet, my suggestion is going to be that you try to flip it and go to problem 5. Problem 5 would be a good one to try. So I'll just put that up so you can see it. Problem 5 is this one right here. So pause the video and give that a try. Well, actually, we're going to end the video here, so we'll see you in the next video. Just make sure you smash that like button, subscribe, tick the notification bell so you don't miss anything, and be sure to visit mrprecalculus.com for all your mathematical needs. Peace.